Now we have Tracy. The first talk was is planned. Well, it was planned to be, Tracy was planned to be over here, but she hurt herself, and so we are taking her on Zoom. Let me connect this, and then I'll quickly introduce Tracy. Can you hear me?
Yes, I can. Is our audio still good here?
The audio is very good. Just give me
Okay.
a couple of minutes so that I can, share this.
And thanks again for, I think I called it an email, the dynamic adaptability.
Okay, yes, you
We
did. And
expect from 5G.
it's our pleasure. It's our pleasure. So let me put this up full screen. Can you see the screen, Tracy?
Yes.
And now you see full screen?
Yes.
Okay, great. So welcome, Tracy. Tracy is a member of technical staff at AT&T Wireless Technologies Labs. And she's been involved in lots of open source projects and standard development organizations. And she's the principal investigator for INDIGO. Let me get this right. It's intelligent 5G networks designed and integrated for globalized operations.
Perfect.
Great. And she's been involved in ORAN, 3GPP, Open RAN activities. And one of the main areas that she's looking at is the security and resilience requirements for military missions and civilian first responder teams. And before joining AT&T, Tracy was a senior technologist at Goldman Sachs. So welcome, Tracy. Floor is all yours. We will click through the slides here. So just tell us, anything that you need control from here. The floor is.
Well,
thank you.
Thank you. Let me first say that, a lot of what I'm about to cover is work in progress for the past 2 or 3 years, trying to bring together artifacts and elements from multiple open source communities, realizing standards, some of them incubated within the ORAN Alliance, some of them more formalized within 3GPP. And now, of course, thanks to here in the United States, thanks to the CHIPS Act, there's actually federal funding to go beyond experiments and demonstrations that are interesting, but somewhat limited unless we get proper public policy support as well as federal funding, which is starting to materialize. Next slide, please. So the main reason I was delighted that I was asked to speak today is because of the National Science Foundation Convergence Accelerator program, which is truly a unique innovation program. I think it will be highly beneficial across the 5G, NextG ecosystem. Of course, the OpenAirInterface community is invited to contribute to any of the NSF Convergence Accelerator teams. I'll show you a list. AT&T is part of 4 of the teams on the list. And I think AT&T realizes, and I'm not AT&T, I don't want to, operators realize that, we need to understand more of what OAI is doing and undoubtedly benefit from some of the work taking place within your, I guess you call them project groups, not working groups. Again, partnerships are everything within this NSF Convergence Accelerator program. Next slide. Looks like we're still on. So there are tracks A, B, C, D. We're now up to track G. There's also HIJ. We're doing work in subsequent tracks. Track G is all about, operating securely through 5G infrastructure, whether 5G infrastructure is a cooperative network, single operator, and you can tweak all the knobs, you can reconfigure anything that needs to be reconfigured automatically, or have a human being do it. Non-cooperative, typically that refers to a home and a visiting network, and from a security perspective, the most you can do is secure the endpoints, or our favorite, if there's nothing available to support first responders, or in this case, their first responder could also be military personnel, not necessarily civilian, create something that doesn't exist. Could be cell site with 5G standalone core on wings. Everybody loves drones, or you could put it in helicopters. You could have cell sites on self-powering buoys, again, with core out there somewhere at sea, which is actually an interesting collaboration going on between AT&T and Naval Postgraduate School out on the West Coast, not far from where you are. But this is, an opportunity for the 5G ecosystem to begin realizing some of the standards and fulfilling some of the potential of some of the 5G use cases that we heard earlier today have yet to be realized, yet to be fulfilled. Next slide. So there are, this is all, and I love the National Science Foundation. It's all out there in the open. Any of you who are interested in what these TRACG teams are doing, almost all of us are including something open, can view the abstract and contact the PIs, principal investigators. The ones that are highlighted in yellow are the teams that include AT&T as a principal investigator, co-principal investigator, or industry affiliate. And of course, I'll talk about INDIGO, intelligent 5G networks designed and integrated for globalized operations. Next slide.
This is taking a bit of... Okay.
But before we called it INDIGO, we called it something else, some other, clever acronym. And it was intended as an all-encompassing use case that would, again, import elements, artifacts from the ORAN Alliance in particular, but also from Linux Foundation, ONF, importing some standards from federal government agencies. It, to be specific, the Integrated Public Alert and Warning System. See if we could get some good results using APIs at the service management layer and level from Telemanagement Forum, and of course, bringing in some standards from 3GPP. I think we were looking at, whatever was next when we started doing this in 2019. And our notion was that there's a city scale disaster, and within less than, time less than 3 minutes, can we, number one, get all the operators who have overlapping coverage in the disaster area notified. And we use Common Alert Protocol, which it happens to be a multinational standard. It's for, I believe, both military and civilian applications. So once the operators are notified, and again, here in the United States, it could be, AT&T, T-Mobile, Verizon, the operators would know that, this is through some policy, stop what you're doing, provide all resource information to, let's call it FEMA, the Federal Emergency Management Association, that will allow the service management orchestration framework to identify which resources survive the disaster and are available for pooling across multi-operator not just RAN, but also transporting core. In parallel, because everybody loves drones, AT&T happens to have a rather sophisticated drone application based on geocast air operations framework, send up a mesh network carried by drones to, with a flight pattern that would be basically based on a service level specification type input, and begin collecting video. And whatever imagery, whatever can be used for optimizing, dynamically optimizing as the situation unfolds. A novel AI planner was envisioned, that's step 7, based on SHOP 3, simple hierarchical planning protocol. So we could tell each of the operators, not in human time, but in machine time, how to, the SMO of SMOs, the Service Management Orchestration Framework, how to slice over time, and at the same time, reconfigure as necessary, if possible, based on inputs from drones and other sources. Send out search and rescue teams, again, keeping this under the actual response time under 3 minutes. And once notification that things are normalizing is received, release the resources and do it over again. So that after the disaster response is completed, the same setup could be used to repair and replace and normalize to pre-disaster. So this was this huge, and next slide, you'll see one of the things that we did within Telemanagement Forum. Oh, well, before we see Telemanagement Forum, we've been working on, again, all-encompassing use case, decomposing it into simpler bits and simpler use cases, sub-use cases. AT&T has acted as the host for ORAN, POX, and PlugFest every year since the inception of ORAN. We've co-hosted with both Verizon and Dish. Same notion, bring in artifacts and elements, concepts from ORAN, ONF, Linux Foundation, starting with simple things. ORAN 01 pre-specification, reprioritizing UE traffic. This is still a problem with management plane, is still a work in progress. 2020, closed loop automation, collecting data via fault and configuration and performance management flows and applying a policy. And of course, 2021 and 2022, this multi-operator environment, trying to realize 3GPP, NRM, RAN slicing control in a multi-vendor and multi-operator environment. At least some of the RAN is somewhat consistent with ORAN. But again, as established first thing this morning, a lot of these standards and specifications are still works in progress. Now the next slide is TM Forum. So here again, putting it all together, we teamed up, AT&T teamed up with Fujitsu and IBM and KDDI. This is not just a North American problem. Asia Pacific and European Union are also hoping to accelerate the potential of 5G and these use cases, some of which are single RAN. We're looking a lot at multiple operator RAN, primarily because it's a good pretext, it's a good reason, it's a good vehicle for getting operators to cooperate, just as we're hoping to get vendors to cooperate in multi-operator, multi-vendor scenarios. So here you see the, what we tried to do. Actually, anybody who knows anything about New Jersey, this is a real area in New Jersey that has overlapping coverage from AT&T and Verizon. Next slide. So we learned a lot doing this, but one thing that we learned is as much as we would like to keep things simple, single operator, single vendor, just deal with a single open source project or open or standards development organization, it really is an ecosystem, a huge ecosystem. So again, one of the reasons I'm here to learn more about what's happening in OpenAirInterface is I believe that some of the work that this community is doing is going to be instrumental, probably indispensable, to solve some of the problems that remain unsolved. Another second and third bullets, or the second bullet in particular, we'll get to the third bullet, it's called out in blue. We meaning, the civilian side of the house can learn a lot from and align with defense and organizations and learn more about military applications that have a lot in common within what needs to be implemented, perfected for public safety. AT&T, of course, we care about public safety first and foremost, where we built FirstNet, but a lot of what we're doing for public safety for first responders meets requirements of here in the United States, the Department of Defense, and vice versa. A lot of what the Department of Defense is looking for to assist the warfighter is very useful for first responders. The third bullet, again, that's why I'm very happy to be invited to speak and learn from the other speakers here today and tomorrow. I think that we'll kind of skip through the rest of the bullets. The moral of the story is whatever we do, whether it's civilian, military, or meaningful for both, must be secure, resilient, and adaptive. And that brings us to 2022, the next slide.
Sorry.
Let's go to the next slide after this. We already talked about DARPA. JADC2 is a DoD vision that looks a lot like the 5G Open RAN, virtual RAN vision. So the next slide, I think, should be INDIGO 2022. There we go. Okay, putting it all together. So INDIGO, Intelligent 5G Networks Designed and Integrated for Globalized Operations. It's a partnership with universities, big corporations, AT&T, Juniper, Ericsson, community activists, Silicon Harlem, and the Diversity and Inclusion Council in the FCC, as well as one or two startups, one of which happens to be High Street Technologies. Next slide. And here I'm going to introduce.
Why don't you introduce this slide and then
Okay.
skip to it?
So the whole point of INDIGO is, again, an AI-enabled network of networks, system of systems approach to allow operators, whether it's a commercial operator, a 5G PCN, private cellular network operator, a defense organization, could be in the United States, could be in, allies, allied countries. So we want to be able to select and secure. And when I say secure, come up with a concept of a quality of security. I know QoS means quality of service, but a quality of security, maybe high, medium, low, for these different network types. Non-cooperative, as I explained previously, it's G.1. It's pretty much all you can do is secure the endpoints. There's more than you can do than that, but you can't really reconfigure or take over the network in any meaningful way. Cooperative, not all that different from AT&T's network, and I'll call it a symbiosis with the FirstNet slice. And tailored, you need to just throw something out there that does not pre-exist. And tailored could be a 3GPP network using some of the deployables from one of the leading, one or more of the leading 5G RAN incumbent vendors, Ericsson or Nokia, of course, in North America. But again, the notion is to do it at, machine time, not how long, not human time. If a human has to do this, it's going to take hours and hours or days. Our goal is to be able to respond to an input and select and secure one of these networks with the appropriate security profile and resilience profile, as well as, adapt to, new inputs about the mission characteristics in minutes, not in days or not in hours or days. Next slide.
Oops.
Nope. Okay. Now here I'm going to introduce my colleague, Dr. Chatai Bukoch, who is one of the founding members of ORAN, as well as instrumental in the creation of ONAP, the Open Network Automation Platform in the Linux Foundation networking. And of course, I don't want to leave out XRAN because XRAN predates ORAN.
Is the mother of
and is the mother of it all. So you move over into here.
Hello,
And I'm going to
everybody.
put my leg up because
Hi, thank you, Tracy. So before I start, I want to make sure that we might be over time a little bit, so I will make this pretty short. Is that okay, Mr. Chairman?
Yes, 5 more minutes. Yes, please.
Okay. Okay, so this slide shows a fundamental concept in networking. Is basically you have a loop. Everything is a loop in networking, and then once you start introducing different networks, different participants into that loop, it becomes more and more complex. So we are here introducing a system of systems. I mean, this is, so to speak, network of networks. So what it means basically is you are trying to achieve something which basically gets input from human elements as well as some other artificially stored elements. And then you make sense of it. You make sure that multiple systems talk to each other through some interoperability. I mean, one of the biggest problems of our age is how to make sure that different systems talk to each other. So that's basically the whole standardization and open systems fundamental question, right? And then you execute, and then this basically is one portion of the loop, and then you measure and complete the loop and adjust, etc. So that's basically the description of the loop. So the picture here depicts some intelligent agent which takes input from like some other human beings or other systems, etc., and then make sure that they are all part of the planning and composition of what you are trying to achieve. So our biggest task here is basically make sure that things are subject to breakdown. And then we say, okay, how do we make sure that if things break down, the system does not break down? So basically, the term resilient I don't know whether you guys know this, but it comes from Italian to bounce back. I mean, if there's an Italian person in the audience, they can tell this better than I can. But I am trying to say this is what I learned. I hope I am saying the correct meaning. Interpretation is the real concept is you have to do something before the system breaks down. So something breaks down, but the whole system doesn't, because you bounce back. So basically that's what we are trying to do. So this 3 applications we show here on the left-hand side, they are shown on the right-hand side as deliverables. Basically, these are different applications that are part of your system that provide input or control systems, etc. So very briefly, so the mission application is the one that sends and receives and manages data from both human experts and other systems, right? So this is something that you need to take into account. Security application is public key infrastructure, attribute-based cryptography, and security is a very big topic, and we have multiple groups within ORAN. It's basically a standalone work group now, work group 11, doing security in ORAN, and in other open systems and other systems, the security is being taken as the fundamental architectural framework as part of during the design stage, not as an afterthought. So, and then resilience is like one of my favorite topics because it's so critical. And then, so resilience basically consists of 2 components. Okay, one is things that you can measure probabilistically, statistically, and then you can actually address the performance of things by measuring performance aspects of it. And number 2 is which we call the black swan events, which basically are things that cannot be measured probabilistically because they happen very randomly, and when it happens, actually it disrupts the system a lot. And then when this happens, what do you do? And then actually that, now coming back to this picture, to the bottom part of the picture, is this is where you have the multi-operator concept comes into picture, because we are hoping that destruction of some Earth event or some any other event that destroys your system partially, you are hoping to put together different components from different operators and create something that will work and at least address your needs that are set forth in the requirements phase. So that's basically this slide, and then I think I ran out of my time, but
Well, if we go, move over for a second.
okay.
If we go, anybody there who's interested in how we've done this so far, and most of what we've done is based on open source projects within Linux Foundation, and I know who the next speaker is, can look in the supplemental material. Thank you very much.
Thank you, Tracy. Thank you, Chitai. We can take a question or 2 if it works. I think with the mic it should work. Any questions here? Yeah, one question that I had was regarding the multi-operator, or how did you call it, the scenario where you're sharing resources. So what's really the challenge there outside of the technical part? I mean, do operators easily,
That is I mean, that's a fundamental question. So I mean, normally competitive operators will not cooperate very easily under normal operational conditions. But we are here addressing a framework for which there is a national emergency or some big catastrophe happening in a region, like Hurricane Sandy destroyed part of Florida or New Jersey, and then nothing is working. I mean, I was left with a house with 16 hours of 16 days with no electricity in my house in New Jersey. So I am assuming in these environments, the operators will be more willing to talk with each other, but that doesn't solve the problem itself. So there are lots of technical problems here that you need to make sure that this SMO or the orchestrators that you are creating have interfaces that can go from operator A and B and then get input and collect all the data and then make sense of it. And then, because not all operators, in fact, most operators don't share same type of data structure. So it's a fundamental question.
And one last thing, as operators, we need to be prepared for the eventuality that civilian authorities will demand this degree of cooperation in the event of the unthinkable. And likewise, military will demand, the same, somewhere in the world, and I don't want to mention regions, there are declarations of martial law. And during those times, our allies need to share and share alike, whatever resources we can pool and help end the conflict and keep our war fighters safe.
Yes, definitely. Thanks a lot for your presentation and your answers. Thank you again.
Thank you.
Thank you.
Oh, Doug has a question here. Maybe you can come here, Doug.
Hi, Doug.
Hi, Tracy. Maybe you can hear me without the mic. I don't know.
Can you hear him?
Yeah. One thing that that impresses me about this is the scale of this kind of a concept and this kind of an effort is almost hard to know where to begin. If you look at, let's say, an OAI, at what appears to be a rather large task with many components and many pieces that fit together, and even hypothetically, OAI is a tiny little component out of a huge landscape of things that involves open RAN technologies, all of the myriad Linux Foundation platform technologies, cloud technologies, and all of the kind of things that we try to work on ORAN, plus industry cooperation to try to come. How do you think we can chart a course to have all of these almost organizations of organizations get together to chart a global vision at this high of a level? Do you think operators will have to fulfill this? Do you think government agencies will be able to fulfill this?
So, Doug, I love that question, and I'm going to answer it very quickly. Thanks to the miracle of the CHIPS Act here in the United States, we are getting an unprecedented infusion of federal funding. National Science Foundation, of course, they have the 10 big ideas, one of which is, convergence research. And it's all about these public-private partnerships. We need federal government support. We need domestic as well as global policy changes. We need contributions from industry, from universities, from OAI, from Linux Foundation. And with that, I will say no more.
I'm a little bit more. Okay.
We don't want to hear anything pessimistic.
You don't want to hear anything pessimistic.
Okay.
I guess Manu is going to reach out to everybody in the industry and follow this together. He's the great unifier.
Yes, definitely. Thanks once again.